Welcome to our new playlist, Smart Contracts for Beginners. If you have already followed our previous playlist, you should already know the basics of Smart Contracts. Today, we are diving in NEAR SDK, the toolkit for NEAR Smart Contracts. What's the two essential functions that every NEAR professional developer should know? Attach deposit and block timestamp, and two fundamental types, NearToken and timestamp. Before we jump into functions, let's understand two crucial types you will see everywhere in NEAR Smart Contracts. I'm going to create a new contract file and show you exactly how these types work in progress. First, let me import everything we need from NEAR SDK. I'm bringing a timestamp for handling time, NearToken for save token operations, the NEAR macro for contract setup, and NVIDIA for blockchain environment functions. Now I'm defining our smart contract struct. Notice I'm using NearToken for all token related fields. This isn't just a number, it's a special type that prevents common mistakes with token calculation. The total deposit field will track all NEAR tokens that users have to our smart contract. For time-based logic, I'm using timestamp. For auction end time, this represents blockchain time in nanoseconds since the Unix epoch. Let me implement the default trait for our contract. For total deposit, I'm using NearToken from NeAR. NeAR is the smallest union of NEAR, like Satoshi's for Bitcoin. For the auction end time, I'm setting it to the large number. That's August 5, 2025 at midnight UTC, represents in nanoseconds. The minimum deposit is set to 1 NEAR using NearToken from NEAR1. This helper function automatically converts to the underlying NEAR representation. Now let's explore NVIDIA attach deposit. This tells you how much NEAR was sent with the function call when someone calls your contract. You can attach NEAR tokens. This function tells you exactly how much. I'm going to write a function that processes payments and shows you the essential patterns every NEAR developer needs to know. I'm creating a buy item function that handles payments. First, I call attach deposit to get amount of NEAR attached to this function call. These functions return a NEAR token, representing the NEAR tokens attached to the current function call. Next, I'm validating the deposit meets our minimum requirement. Notice, I can directly compare NEAR token values. The SDK handles this safely. If the deposit is too small, I panic with helpful error messages using as_NEAR to display the amount in human readable NEAR units. Notice, we use saturating add instead of plus equal because NearToken doesn't support direct addition. This method safely adds the deposit to our total saturating at maximum value if overflow occurs. Next, block timestamp that gives you the current blockchain time. Unlike your computer's clock, this deterministic blockchain time that's the same for all nodes processing the transaction. Let me show you how to use it for time-based logic in NEAR Smart Contracts. I'm creating is auction ending function that checks if our auction has finished. The block timestamp function returns a timestamp U64 representing nanoseconds since Unix epoch. The timestamp is related to the block in which the transaction is being processed and remains the same through the whole function execution. Our contract's auction at time is set to this large number, that's August 5, 2025 at midnight UTC in nanoseconds. I simply compare the current blockchain time to our stored end time. If current time is greater than or equal to the end time, the auction has ended. Okay, let's deploy our smart contract. For this, I will type cargo NEAR, deploy, choose my testnet address, no initial call, testnet, continue, send. Yeah, it's successfully deployed. Let's read our functions. I will go NEAR contract Call function, read only, because I want to read is auction ended. Testnet now. Yeah, you can see it shows true. It's totally correct. Now I will check by item. Yes, transaction, because it's mutable self. Here I will write 1 year because I'm attached deposit. Send. And here you can see that I have an error, and it's totally correct. Because in the next video I will explain why, because here we forget payable. It will be our next part of SDK in the next video. That's your start in NEAR SDK. Today we covered NearToken for safe token handling, timestamp for token logic, attach deposit for handling payment, and block timestamp for blockchain time. Ready to build real-world smart contracts that handle actual payments? Subscribe and hit the bell. The NEAR SDK's only start. If this video helps you, drop a like and write in the comment what dev do you want me to build and what problems do you face. See you next time.